Hello and welcome to another one of D's ADD videos. Today we're going to look at a few basic examples of Lewis structure. So when drawing Lewis structure for an element, what you do is you basically write down the element, look up its valence number, and if we were to look up magnesium, magnesium is right here. It's got 2 in its valence shell indicated by that 3s2. So we would just put one dot and then another dot. Doesn't matter which order you go in. Oxygen, however, has 6 electrons in its valence shell, 2s2, 2p4. So when we do oxygen, you write down the element and you put 1 on each side, and then you start pairing up. Your 6. Okay. Now methane, you have to start using your rules for methane. So the first step in drawing the Lewis structure for methane is calculating the valence electrons. If you look at carbon, carbon is in the 4th column here, and hydrogen is number 1. So what we what we have is 4 plus 4 times 1. That equals 8 total electrons. So that's your bonding electrons and your lone pairs. So when drawing the skeleton structure, which is the next step, normally you would put the least electronegative element in the middle. But in this case, hydrogen, the least electronegative element, is only able to make one bond, so it cannot be the central atom ever. So if we were to subtract the bonding electrons, so minus 8 bonding electrons, we should have 0 for your lone pairs, which indeed we do. So to make sure everything's on point, let's calculate our formal charges. So the formal charge for the carbon, let me do the formula. The general formula for formal charge is the valence number minus the number of bonds plus lone pair electrons. Alright, so our valence number for carbon is going to be 4 minus, it's got 1, 2, 3, 4 bonds, and no lone pairs. And it's neutral, as it should be. And then the formal charge for the hydrogen, we only need to do one formal charge calculation because they're all hydrogens with a single bond to a carbon. So if you do one, you do them all. 1 valence number, 1 bond, 0 lone pairs. So the net charge, the net sum of these formal charges should be the net charge of your compound. In this case, methane has no charge. So when we added up all these charges, if there were some, it should add up to 0. Okay. All right, for a final example on these basic rounds, we're going to do ammonia. Ammonia is a base, and basically we have 5 for nitrogen. If you look up on the periodic table, nitrogen's in the 5th column. So plus 3 for the hydrogens gives you 8 electrons. Again, because of the bonding limit of hydrogen, we have to put it on the periphery, not as a central atom. So then we do a single bond, and right now nitrogen is deficient. All right, it doesn't have its octet 8 electrons surrounding it. So what we would do here is we would subtract the 6 bonding electrons to give us 2 lone pair electrons. Well, guess where those go? The only place they can go is on this nitrogen. So let's see if this is valid. Let's do our formal charges. Formal charge for nitrogen is going to be 5 minus the number of bonds is 1, 2, 3 bonds, plus 2 lone pair electrons. Notice I counted each one, not both of them as a pair. You have to do each one. So 5 minus 5 is 0. And then the formal charge for the nitrogen, or the hydrogen bonded to the nitrogen, 1 valence, 1 bond, 0 lone pairs. And that should be a minus sign right there. Sorry. So neutral again. So that's valid. All right. Again, if you have multiple choices for Lewis structures, sometimes you'll have this will work and something else will work and something else electron-wise. You want to pick the one that's got the fewest formal charges and the most number of bonds. All right, I hope these basic examples have got your fundamental questions and doubts out of the way. Make sure you check out the intermediate and advanced examples as well. Most importantly, practice, practice, practice. Thank you, and have a nice day.